for Professor. So I just finished my PhD this last year, and now I'm working as a postdoc here. So you can just call me Andre. And basically what this class is going to be about is kind of like an introductory tutorial to Jupyter Notebook. And I'm sure a lot of people have a lot of experience with Jupyter Notebook, a lot of experience with the programming, but there's some students that don't, and we need everybody to kind of like understand at least the very basics. So when we do projects in this class, like using Jupyter Notebook, like there has to be some sort of foundation. So let me ask a quick question to everybody. Does everybody have access to Jupyter Notebook right now? And if you're online, can you just drop a yes or no in the chat so I can get like a gauge of where we are as a class? So everybody here has access to Jupyter Notebook already, right? Yes. Yep. Awesome. All right, that's good. And so for the purposes of this meeting or this class, I'm just going to go real quick over like how to launch it. So if you're using either Windows or Mac OS, the easiest way would probably be to use Anaconda, and it's quite easy. You just go to Anaconda, Google Anaconda, get the Anaconda Navigator, and from there you'll be able to launch PowerShell with Jupyter Lab, Jupyter Notebook, whatever. If you're using Linux, the easiest way would probably be to just do pip install. So like if you have Linux and you already have Python 3 on there, you should automatically have pip, which is the Python installation package manager. And you just do pip install Jupyter-lab, and it'll get you everything you need. So everybody here has experience with programming in Python, correct? And if you're online, can you just drop a yes or no in the chat so I can get a gauge of All right, sounds good. So what I'm going to do real quick first is show you guys a cool tool that's on Google Drive, if you guys didn't know about it. So it's called Collab Notebooks, Collab, not like collab. It only has one L. So you can just type in Google Colab with one L. And then it has this like collaboratory kind of thing. Since everybody has a Google account for their NJIT email, everybody has access to a Google Drive, and everybody should be able to, if you're connected to your Google account right now, when you click on Welcome to Collaboratory, it should bring up some screen like this. And then what you can do is you can click New Notebook down here, and this will kind of take you to an online version of Jupyter Notebook that you don't have to install on your computer. It's a little bit different than Jupyter Notebook itself, but it's quite useful because it also uses the Jupyter Notebook Python file extension, IPYNB. And it's useful because you can just save it on your Google Drive, and you can share it with friends or like work on some stuff together. If you're working on a project together, you can all just have access to a shared folder since everybody in this class has a Google Drive. It's a very useful tool. So today we're going to be just covering a really basic stuff. And if you guys like, I'm sure most of you guys are like very intimately familiar with a lot of the things that I'm going to be going over, but in case some people aren't, it'd still be a good thing to cover. So what I'm going to be showing today is how to, well, depending on the times we get, I'm going to show how to use the basics of Jupyter Notebook. And in that, I'm going to be showing you guys how to read an ASCII encoded file, to take the contents from that file and plot them out. I'm also going to be showing you how to read a FITS encoded file, and we'll get to that when we get to that. And then finally, I'm going to be showing you guys how to create a small animation inside the Jupyter Notebook itself. So all useful tools for all the tools you're going to need to know for doing the homeworks or doing some of these projects. So the first thing I want everybody to do is go to Canvas. because there are some files that we're going to be using there. Let's just log into Canvas. Go to Courses, Intro to Helioseismology. And then you're going to go to Files and Course Materials. Inside here, you guys are going to find a folder called Jupyter. Click on that, and there's going to be these 3 files. I'm just going to wait a little bit for everybody to get there. Everybody already on the page? Awesome. So just take each one of these files, download them, just click Save File. We'll take a look at them in a second. Then you can go to your Downloads folder and maybe move them all to Documents. Or if you want to create a folder in your Documents folder for this stuff, just move them over here. So eigenfun cs.f_frs.fits and eigenfun r_frs.fits, these are fits files. So we're going to go over those later. But basically, FITS is an extension that's used in pretty much all of astrophysics. So if you're going to be collaborating with any outside groups, working on any projects with other schools, or, for example, other like governmental agencies like NASA or any national lab, everybody who's in astronomy or astrophysics is familiar with the .fits extension. And it's the way that you guys are going to be transferring files back and forth between groups. So knowing how to open and write FITS files is going to be very useful for you guys now and in the future. And finally, we just have a regular data file. So this is, you guys can click it open. So this is what's called an ASCII encoded file. It's basically formatted. So there's 2 different types of files in programming, unformatted and formatted. And unformatted files are just binary. You can't read them, but a program like Python or C or Fortran can read them directly into it using different the different file reading libraries that they have. But a ASCII or formatted file is one that you can just open up in a notebook or open up in Emacs or open up in Vim and just read it yourself directly. So this file that I'm opening up is basically an LNU diagram. Just to refresh your guys' memory, quickly look up LNU diagram. And this is the kind of thing I'm talking about. Here's a bigger one. So in yesterday's lecture, I'm sure you guys learned about P modes, which are just the acoustic eigenmodes that resonate within the sun. So in the top 30% of the sun, in the convective zone, when the frequency is much higher than the cutoff frequency, and the frequency is much higher than, for example, Brunt-Weissel frequency. I think last week you guys figured out how to solve for the angular frequencies of P modes. And these are just the standing waves that resonate within that top 30% of the sun and have turning points at the surface and the inner turning points somewhere within that convective zone. So those equations that you guys solved last week, they can be solved directly. And this file right here is an example of the solutions to those equations. So the first column is just the number, the index of the line. So it goes from 1 to 7,592 because there's that many lines. So the second column is N, or radial order. So for example, if you guys remember the LNU diagram, each one of these ridges is a different radial order of the eigenmode, of the oscillating acoustic standing wave inside of the solar interior. So like the very first one down here, this very faint one, would be the first radial order, then would be the second, third, fourth, fifth, sixth, so on, and going up in frequency along the ridges is a higher and higher radial order. So down here is the angular degree, which is the spherical harmonic decomposition, or Legendre polynomial decomposition of a sphere. And L is just the power, the degree of that decomposition. So last week you guys solved an equation for omega NL, omega underscore NL, which was the angular frequency for a corresponding angular degree L and a radial ridge N. And this file is basically just exactly that. So the first line we have basically the 0th radial order, and then we have the corresponding L's, the angular degrees for that radial order, and then finally we have the corresponding values of omega. Sorry, wait, I got that backwards. This second column right here is the angular degree L, and this is the radial order. So, for example, we can see for L equals 0, it solves for radial order 2, 3, 4, 5, 6, 7, and so on. So if we look at the LNU diagram at angular degree 0, each one of these radial orders has a solution and a corresponding frequency that's here on the y-axis. And it's the corresponding frequency is this third column here in millihertz. So real quickly, if you guys are interested in using the Google Colab notebooks, it's a little bit different because you can't directly access files on your computer system. So I'm not going to do this right now. I'm just going to move on to the example. But basically, what you want to do is you want to open the files. Then you click this little button here, Mount Drive, and then you click Connect to Google Drive. And when Drive pops up, you can double click it here. And click My Drive, and it will give you an access to all the files in your Google Drive. So those files that we downloaded from Canvas, what you can do is you can then go to your Google Drive, upload them directly to your Google Drive, and then access them in this Google Colab notebook this way. But I'm going to be using the regular Jupyter notebook right now. And this is just like an interesting tool if you guys want to collaborate, which is what it's called. And it's almost exactly the same as the Jupyter notebook, but it runs on this kind of proprietary Linux system on Google servers. So it can't do everything that your Jupyter notebook can do. For example, plotting, you can't use plotting because it doesn't have a backend to animate it the same way that Jupyter notebook does. And you can't do moving animations because it doesn't have the same kind of backend to animate them. It's just a very simple kind of Linux thing, and they don't have FFmpeg decoders on it, so it's not going to be able to run an animation. But well, if you don't understand that, it's okay. We'll get to all that later on. So just you can launch Jupyter Notebook pretty easy. Go to Anaconda Navigator, click Launch, or if you use command prompt, you can do something like in Windows it'll be Jupyter Notebook and launch it that way. In Linux it'll be Jupyter Lab, and I'm not sure on Mac, but I think in Mac it's also Jupyter Lab, very similar to Linux. Or if you're using Mac, it might be just easier to get the Anaconda Navigator. So once you have Jupyter Notebook open, you can go to Documents And wherever you save these different files is where you would want to navigate to, just to make things easier. You can put it all in one folder, or you can actually do it from different folders, but it'll just make things a little more complicated for now. Then what you're going to do is you click New, and in Notebook, you should have two different kernels. So it's either going to be a Python 3 kernel or a Python 2 kernel, depending on what you're working with. Since this is kind of a very introductory type of class, we're just going to go with Python 3, the newest, the one that probably everyone has. And basically just click this Python 3. And this creates so this kind of mounts the Python as the kernel that runs Jupyter Notebook. It's not really important what that means, but basically you can run Python, you can execute Python 3 code here. So now that we finally got Jupyter Notebook open, we're gonna take a quick look at how to write things. So the great thing about Jupyter Notebook is that it's really good for not just having it as a notebook yourself, but you can actually just print it out at the end as a PDF or as an HTML and actually submit it as homeworks to another class. So for example, if you ever need to make a plot, if you ever need to solve equations, if you ever need to do anything like that, you can basically format it very similar to LaTeX, to a LaTeX document, and you could do it all on the fly, on the spot right in front of you. You can actually save it as a LaTeX format and directly print out a beautifully formatted LaTeX page with all the graphs you already did, and then you can just send that out to whatever class you have homework in or whatever project you're working on, and it makes it so much easier. So to learn how to do this, we're going to first learn how to, instead of just writing code, also write text. So what you do is in the first cell from code, you switch to Markdown, and Markdown basically is the LaTeX interpreter for writing down text. So one thing we can do is we want to make a title. So what we do, we would hit the pound sign, hashtag. What do you call this thing now?
Yeah, pound sign, I guess.
We'll go with hashtag for the new generation. Okay, and then you can write, for example, what we're going to be doing is we're going to be plotting our own LNU diagram using this text file. So we can just write plotting LNU diagram, and then click Shift Enter. Great. Got to put a space between that hashtag, and then you have this giant title. Now I think it's too big, so I want to make it a little smaller. I want to make it like the size of a subsection. So what I'm going to do is I'm going to put another one. Take a look at that. That's a good size.
I'm sorry to interrupt you.
Yep.
How did you make the title?
Oh, yeah. So the title is basically what you do is when you open Jupyter Notebook, you're going to have this kind of cell that's code. Delete a cell. Oh, there it is. So when you start Jupyter Notebook, you're going to have a cell that runs code. So something like Python code. But if you, instead of code, you want to write a text, all you got to do is go from here and change the nature of the cell from code to Markdown. And this way you'll be able to write text. And now you can just write text directly. But if you want to make it look like a title, you can put the pound sign or the hashtag in front of it, space, hello, and then it'll be like a large paragraph title. So I think this is too large. I don't like it. It doesn't fit with my aesthetic of the page. So I'm going to make it a bit smaller by putting 2 hashtags. I don't know. And then finally, you can make it even smaller with 3. And this is like subsection in LaTeX or in Word when you're creating documents. I'll make it a little bigger. There it is. And I'm going to write plotting L new diagram. Awesome. Except for this looks like an I. So I'm going to put the LaTeX style number signs which denote math. So when you put in a number sign and then you close it off with a number sign, that means inside of this region there is math. And the reason I do this is then when we write L new, they usually have this distinct italicization, which corresponds to mathematical equations. So it creates this nice math look for it. New, let's make it the actual Greek letter. And the way we can do that is inside of these inside of these dollar signs, what we can do is we can put a backslash in front of the new, and it turns it into a Greek letter. And you can do that with all the other Greek letters you want. As long as you put a backslash in front of them and write them, and as long as they're inside of these dollar signs, they will show up. If they're outside of dollar signs, they're not formatted using LaTeX. They're formatted using Jupyter Notebook's just text, so they won't become Greek letters. So plotting L new diagram. I'm going to create a markdown for the next one, and I want to kind of delineate this to make it look nice, make it look fancy and presentable. So I'm going to make a line for the title. And the way you'd make a line is by putting 3 stars in a row in a markdown cell and press Shift Enter. And it's really hard to see, but whatever. And this kind of like delineates the title and then the line, and then we can start writing what we want. And I'm going to click Markdown again. And for example, if you guys are doing any like LaTeX or word processing yourself, like for projects or whatever homeworks or whatever you're working on for yourself, then you can begin to outline a small description of what you're going to do in this Jupyter Notebook. So for example, I would write, this is going to be a small tutorial on how to use Jupyter Notebook, period. Awesome. So, and I heard that everybody's familiar with Python, so I'm not gonna bore everyone with too much details, but I'm gonna go a little bit slowly in case somebody doesn't know or somebody isn't aware how to do certain things. So what we're gonna be doing today is we're gonna be plotting things out. So the first thing we need to do whenever we plot stuff out is we're going to need to import a certain package called matplotlib. Oops, that's marked down. So in the first code cell, where it's out form code, you will write import matplotlib.pyplot as plt. Basically, matplotlib is a library for plotting in Python. It has like all these different objects inside of it. Like it can create figures, it can create axes, it can create grids, it can create lines, it can create dots, circles, and then it can like arrange these basically figures in a way to make a plot. And this is all done inside of this library called matplotlib, or matrix plot library, I guess it's safe for. Or mat. I'm not sure if mat is from matrix or MATLAB. Maybe they ripped some stuff off of there, but who knows? And then you do .pyplot. So pyplot is a specific backend in this library. It's the way you plot things. So this is not something you're going to need to know about. You're just always going to be using .pyplot as a general rule. If you use Python outside of the Jupyter Notebook environment, you might use a different backend to animate your figures. So pyplot is basically, it takes all of the shapes and objects that the plotting library created, and it arranges them in a way that it can draw them on your computer screen. So that's what a backend is. And there's different types of backends to use for different reasons. But basically, most of the time, you'll just be using the pyplot backend. And you can import this whole thing as PLT because it's a lot shorter than writing out matplotlib.pyplot every single time. So another thing we're going to import is NumPy. So hopefully everybody is familiar with NumPy. And NumPy is basically just a library for creating and using arrays efficiently in Python. So Python is basically a wrapper for the C language. And NumPy is just a library for efficient usage and multiplication and for using formulas for matrices written in C and then used as a wrapper for Python. And it's really efficient. Could be, depending on how you implement it, it could be as fast as C or it could be as fast as Fortran. Usually it's not some other Python stuff around it, but it's a really good library to use whenever you want to use linear algebra or matrices or anything like that. Click Shift-Enter to import it. And then next thing we're going to do is we're going to have to read the files. So, make a little markdown maybe, and then write, now we import the plotting data. Shift-Enter. Markdown. Sorry, not markdown, code. And to import data from Jupyter Notebook, this is why I told you to navigate to the same directory that you have saved those files. Because if you open Jupyter Notebook in that directory, it's already open in this directory. How you can check is write ls, and it'll show you what directory you're in, and it shows you the files that are in this directory. It's ls is a Linux command or Unix command, and it can also be used in Jupyter Notebook or in Google Colab, and it's just like a quick way to check what directory you're in and what else is in that directory. So basically we see, oh, perfect, this is the file we want. So this is the file we're going to open. So we write file equals open parentheses, and then you open these apostrophes, and then you can just start writing the name, FR5. Wow, that's really complicated, don't want to write the whole thing. Just click tab, and it should auto-complete it. Unless there's something else in that directory named FR5 something something. Okay, then we can click Shift-Enter, and it loads up the file. Fantastic. So we can just print out file, see what exactly it is. It looks like some kind of object that opens the file. It says mode R, that's good. But let's just specify that directly ourselves. So when you open a file, you can write a comma, and inside the apostrophes, you can write R, W, RB, or WB. So R and W are for reading and writing ASCII encoded files. So like we went over in the beginning, anything that can just read as a text file in your Emacs or your notebook or whatever. And then RB is for reading and writing binary files, but we're not going to cover that today. The only binary files we're going to be reading are FITS files, because they're the ones that are most used when collaborating or working with any type of projects. So now that we open the file, we're going to have to read it. Is everybody familiar how to read from a file line by line? Kind of?
In a loop?
In a loop, yeah. Well, for those who aren't, let's just cover it real quick. All right, so everybody's familiar with a loop, right? In Python, you can create a list of objects, a list of anything, a list of numbers, 1, 2, 3, 4, and it's easy. You just do list equals, and list is the object, and the object is of type list in Python. The way you open it is by opening brackets, not parentheses. So make sure you use brackets. And then you have a list, and then what you can do is just print, or this is Python 3. So you're going to have to open and close parentheses and print list, and boom, you have your list. Doesn't have to be numbers. Could be a list of anything.
Andrei, excuse me.
Yes.
let's check if everyone follows you. So it, Bryce, you follow, it's okay with you?
Yes. Is everybody following, or
Okay.
does anybody have something that they weren't able to do and is still struggling and is still stuck on that?
I can't open the file actually.
Sure. For the so this file you downloaded it from the Canvas, right?
Yes, and I saved in just desktop.
You saved in desktop, and then
Yep.
you open your Jupyter Notebook in desktop, correct? So when you open Jupyter Notebook, it looks like this, and then you're going to have to navigate to desktop, and then you opened it in your desktop here, right?
Oh. Okay, I'll try again.
You got it?
Just a moment.
Sure.
I says no such file or directory.
So let's see. You open Jupyter Notebook, and does it look like this? Like the thing I have on screen now?
It looks like that.
Yeah. And can you click on desktop?
Mhm.
Yeah. So when you click on desktop, you should see the 3 files that you downloaded. Correct?
Also, not folder, just 3 files on desktop.
Yeah, the 3 files. One is called eigfun r something, or the other one is called eigfun cs something, and the third one is called fr5, some very complicated name. Do you see those 3?
Oh yeah, but yeah, I tried, but there's not error, but nothing happened.
So did you open the notebook inside of this desktop?
Yes.
Okay, and when you ran the command ls and pressed shift enter, did you see the files in the desktop?
Yes.
Yes. So then this should absolutely be working, because this doesn't have any specific packages that Python doesn't have, Jupyter Notebook doesn't have initially. So maybe you wrote the name wrong, or if you click tab, it should have auto-corrected the name for you, or you can just copy and paste it from here. You just take it here, control copy, put it right here, and paste, and it should read it without a problem. Are you still getting the error?
Then there should be any script coming up, or just.
No, it'll just be like that.
Okay, then I think it's done. Thank you.
Okay. Well, if you can't follow along, or if you're getting stuck on something, it's okay. I'm gonna upload this Jupyter Notebook into the same folder where you guys got these files from. So if you think you did something wrong in your Jupyter Notebook, don't worry. I'll just upload mine, and you guys will be able to download it, run it yourselves, maybe even put it into Google Colab. So don't worry too much about it. And then, of course, Professor Savichev is recording this, so in case you need a reference, I'm sure he will upload it to the website as well. And then you can just rewatch and like run along with this if something's not working. And if you have any questions, just don't hesitate to unmute yourself and just ask. All right, so let's back to the list. So the list can be anything. It can be numbers. It can be strings. So what it can't be is just words, because Python doesn't know what to do with a word. So if you're saving a list of words, they have to be in the format of strings. And the way you format that is you put an apostrophe on each side, or you can put a quotation marks on each side. It actually doesn't matter. So the way that we can go through a list is by using loops. So I'm sure everybody's familiar with loops. If you're familiar with programming, all of programming foundationally rests entirely on loops. How these computers run, it's all loops. So if you're going to know one thing in programming, you're going to know how to write a loop. In Python, it's quite easy. It's very straightforward. You just do a for loop, and you write for I in list. So this I is just any variable. I is the most commonly chosen one because it just represents index. So for index in list, and then a colon. So whenever you have a loop in Python, it has to end with a colon, because when you press enter, it'll create a little indentation. And you have to run your code inside this indentation. That means it's inside of the loop. So for example, if I write print I and then run it, it'll cycle over each word in the list independently. So for I in list, a list is an object. It's a list object in Python with 3 indices. So what a for I in type of a loop does is it'll say, let's take this list object and we're going to cycle over each one of these indices in a loop. And then the value of that index is going to be I. So it's pretty easy. You have a list, and for every single index in the list, you print out the corresponding index. So you can have print I, you can have a mixed string slash number with different types of numbers. You can have an integer. You can have a just a float number, or you can have a string, and you can iterate over this list. And one thing very useful to know is the easiest way to create a list of numbers in Python is using range. So range, like let's say range 10, creates a list from 1 to 10, but actually 0 to 9, because in Python the initial index is 0, so it just moves everything back 1, which I find kind of annoying actually, but what can you do? It's Python. Basically, so what you do is same thing. Range will just create you a list of numbers, and it could be very useful, you know, when you're doing calculations or when you're doing whatever. Range is really easy to use. You can do 0 to 10, or you can do 5 to 10, or you can do 5 to 20 every second step. So if you have 3 numbers in the list, it's the first, the last, and the step size. Run it, they get 5, 7, odd numbers up to 20. 5, 7, 9, 11, stuff like that. And if you want, you can even count down. So you want to count down from 20 to 5, and then the step size will be -1. And now it's countdown from 20 to 6. It's just how, it's the easiest way to run a loop in Python. It'll just be a loop of over whatever number range you want, and you can do whatever you want with those numbers. Real easy. So basically, this is how you read a file in Python. It's I have to open the file again because Python doesn't like it when it's in different cells. So open the file and put your reading loop in the same cell. And then what you're going to do is for line in file. File. And there's gonna have to be something in the loop, and you can write print line. Awesome. There we go. So when Python opens a file, it naturally opens it as a type of list where each index of the list is the next line. So for example, we have this ASCII encoded file, and it has these 7 columns. And at the end of the columns, it has an ASCII type of encoded parameter called new line, which is just \n. And that tells the ASCII, and that tells Vim or Emacs or Notebook to create a new line and put the next column, put the next row after it. So every time it hits that new line marker, it means that it automatically puts it into the next index of the list in file. So it makes it really easy to read line by line. Now, we can see that it actually reads everything. So not only did it read the whole row, it actually also read the for the \n, which we can't see here, and create it into a new line. So now we have, this row, then we have new line, then we have row, new line, row, new line. We don't want to deal with that. We want to remove all kind of ASCII encoded stuff. And you can do that by writing line.strip, open and close parentheses. And then what this will do, it'll strip out any unnecessary stuff. So if there's white spaces at the end of your lines, or at the beginning of your lines, or if there's new line characters, if there's tab characters like forward or \tab, it'll just strip them out, and it'll just give you the line directly from the ASCII file. Now what we want to do is we want to take each one of these indices individually. So it's great that we're reading all the lines, but basically we want to read every single cell individually. So the way we can do that is we can do this line.strip object. We can write line.split, open and close parentheses. Boom. And this what this does is that every single line it reads out of the file, it'll split it into a new list of 7 different rows. And it's splitting wherever it saw in the original line a space. So this is actually the same thing as if we said space bar. So inside of split, you can denote where to split. You can actually just split it at periods instead. So every time there's a period, it'll split it there instead. Oh, too many quotations. And now it's split it based on where it found the periods in the line. We don't want that. We want it to split wherever it finds spaces. That's a little much, or whole spaces. And you can do that just by doing split by itself. It's very handy in Python. Python makes everything very easy to do. So now we're going to want to put this into an array. So if we're plotting an L new diagram, we're going to want L and we're going to want new. So this column, this first column of zeros here, that's the corresponding L, or the spherical harmonic degree, and this is the corresponding new in millihertz. So we're going to want to pull them out of this list by themselves. That's what we're interested in. So let's create an array that we're going to end up dumping them in. So let's see. Best way to use arrays is NumPy. It's the fastest. So we can write something like L underscore R, which is going to be our L array. And it's going to be np.empty, which takes the NumPy library and it creates an empty array. And now we're going to have to specify what the shape of the array is. The shape is, well, it's going to be just a vector because we just want the L's in this one. We can do a 2-dimensional array, but let's not do that right now. You guys can do that later if you want. So we're going to have to specify some length. Not sure what the length is. Easy way to check is I equals 0. And then every time it loops over the file, you do I equals I, or I plus 1. And then once we're done with the loop, just print out I, and it'll tell us the length. Every time the loop loops, it adds another index to I, and this is our length. So I wrote I equals I plus 1 just for clarification, but the way that most people do it is I plus equals 1. There's really no reason to. They just think it's faster because it's 1 space less, but like it really doesn't matter. But if you want to do add a 1 to a variable in Python, every single loop, you can just do I plus equals 1. So now that we have this L array, what we're going to do is we're going to dump the output that we got into it. So LR, open and close the brackets, and we're going to do I. So another reason I use I to read how many spaces there were in the array is because we're going to use I again. And what we're going to do is have it cycle inside every index of this array. So you take the array, you open it, and then I will be whatever index you have. We start with a 0th index on the first line of the file. So the 0th index will be the first line. It would be just line. And if we want to split that strip, and we want to take the first column of that line. Oh, maybe I should show this. That's important. Oops. Put that backwards. There we go. So this is the original line. And basically, it's a list of numbers that were in that line. And then we can index that list. So the first index of this list is this one here, and this whole column here. So if you do the 0th index, it'll just print every single 0th index of every line. If you do 1, it'll print every single first index of every line. 2, it'll print every single second index of every line, and so on. So we want the L's, which are the first index, and then we're going to dump it into LR equals. So the ith index of LR is the first. So we start with I equals 0. That's the first line of the file. LR, the very first index of the vector, index 0, equals the very first line. And then the line is split apart, and we only take the first index of that line, and we dump into LR. Next time, and then we do I plus equals 1, or I equals I plus 1, and next time we loop it, we get I equals 1, and then it'll be LR I1 equals the second line, and it'll be another loop, it'll be I equals 2, that'll be the third line, I equals 3 will be the fourth line, so on and so forth, and it's all just going to dump it into this array. Yes?
Is LR a list or an array?
LR is an array. Great question. And the way you would want to make sure of that is you can write int and convert it to an integer just to make sure. You don't have to. Or you can do, but you really don't need to do that. That's a great question. So there's two different objects in Python that you use. One object is the list object, which is the one I showed earlier. And then the other object is that the one we created is a array. So you can't see, like, there's a 1 here, there's a banana here, there's a 4 here. You can't take list and multiply it by 4. Like, that doesn't make sense. You can't multiply banana by 4. And the same thing with the numbers. The numbers aren't actually saved as integers. They're not actually saved as numbers. They're saved as kind of instances of some character, which just happens to be a number. But when you're using an array, it's really easy to do linear algebra. It's really easy to do regular algebra. You just do LR times 4, and boom. Every single one of the vectors, or the individual indices in this vector, gets multiplied by 4. And then you can do vector by vector multiplication. Very easy. LR just times LR. And it's just every single index of the vector is multiplied by every single index of another vector, or the same vector. So this is why we use NumPy instead of lists when we use when we're working with reading vectors with integers or floats and stuff that we generally want to do mathematical work with or plot out. Thanks, that's a really good question.
So as a bottom line, we use lists with some programming stuff, or
you should not use lists. If you're using with numbers, you should always use vectors and matrices. Because even if you try to plot a list, it won't actually plot the numbers. It'll treat the numbers in the list as an individual character. So you can't do math with it. You can't like plot it out properly. Like if you plot out a list of 1 to 5, it's not going to plot a list of numbers from 1 to 5. It's going to plot like this is a character called 1. This is a character called 2. This is a character called 3. And the plotting program won't be able to like put them in order by itself because it doesn't understand the fact that they're numbers. So we'll get to that later. But basically, you should always be using these vectors and matrices from NumPy or pandas, but NumPy is the easiest one, so we're just going to use that. You should always be using them when you're doing math. So we're going to create a new vector. We're going to call it new array, because it's going to be our x-axis of our y-axis of the plot. So it's going to be frequencies, new. It's an L new diagram. So we just take this, we copy it, boom, we drop it. New array equals, and what was new? Anybody remember? Well, you know what? Let's just print them out and check. Okay, so it's obviously not the first index. Let's check what the second index is. Nope, that's radial order. Third index, there it is. Frequencies in millihertz. Awesome. This is what we're looking for. So now we can print out LR and we can print out new R, and it'll be our L array and it'll be our new array. So now that we got everything done, we want a little description of what we're going to do next, because that's how good projects look. They have comments and stuff. I haven't been commenting that well, but I'm sure you guys will do better than me. So what we do is we're going to say, now that we have our data, we are going to plot it out. Awesome. So we have matplotlib.py as PLT. Pretty easy to plot in Python. All you do is plt.plot, open and close parentheses. It's going to be your x-axis first, which is L array. It's going to be the y-axis next, which is new array. And you click Shift-Enter. Looks awesome. But we're going to make it look even better. So for some of you, the plot may not have come up because you have to specify that you want it to be inside. You want it to show inside of the Jupyter notebook. So some of you may just have this output, which is just the plot object, and for that you're going to need to write %matplotlib inline, and it's good. And it's good Jupyter notebook kind of a good idea to always just have that whenever you're using matplotlib. So wow, let's check. Does this look like an L new diagram? No, not really. Why is that? Well, because we're plotting. So we have this array. We have 0, 0, 0. So we have, for the first L max, we have 0, 0, 0. And then for every single radial order, we have the corresponding frequency. So it's plotting from 0, plotting to the next 0, plotting to the next 0, and going back to 1, plotting for 1, 1, 1, and going all the way down, plotting for 2, 2, 2, going all the way up. So it just colors everything in because there's just so many lines. So apparently plot is not the best way to visualize this specific data. Luckily, we have other tools to visualize this data, such as a scatter plot. And it's really easy to run that. All you have to do, instead of plt.plot, you write plt.scatter. Ah, now this looks like an L new diagram, kind of. Let's see. One that goes to 1,000. This goes to like 3,000. Sure. Anyway, we can see that this is a fantastic looking L new diagram. Well, fantastic is a strong word. It actually looks terrible. So let's make it look nice. Let's see. What can we do with scatter to make it look nicer? Well, first of all, I don't like the size of this figure, so I'm going to change that. I'm going to write plt.rc params figure dot fig size equals 10, 5. Yeah, that's better. Fits into the page better. So pyplot or the renderer, the backend renderer has different parameters for how everything looks. So you can access that by writing plt.rc params, and then you can write the parameter that you want to change. It's going to be a list of different parameters that it has, the object has, and one of the parameters is figure.figsize, and you can change it to whatever fig size you want, depending on what looks best for you.
Is it aspect ratio?
Say again?
Is it aspect ratio of the figure? Not
Yeah, no, it doesn't change aspect ratio. Like you can just do 10:8, and now it'll be longer. You do whatever you want, whatever looks best for your document, whatever helps tell your project, the story of your project better. Speaking of story of the project, I don't like the size of this font. I'm going to change that as well. Same thing, plt.rc params. We're going to want to work with a font, so it'll be font.size. How big are font sizes in this? 15. Not too big. I don't like that. Let's do 12. Yeah, that's good. Now, if you showed somebody this graph, they'll be like, I have no idea what I'm looking at because there's no labels. So that's what we're going to do, is we're going to add a couple labels. Yes. So plt.x label, and we're going to write a label for it. It is Angular degree. L. And all of a sudden, we have a label for the x-axis. Angular degree L doesn't look professional enough. This L looks like an I. So let's do the same thing that we did in Markdown. We open the $sign and we close the $sign around L. Now this looks professional. This L actually looks like an L in math. This is great. Y label, we can do something similar. We do plt.ylabel. Open up our quotation marks, because you need, whenever you're writing in Python or Jupyter Notebook, you're going to need quotation marks because it doesn't know what to do with the actual letters. It has to be inside of a string, and these quotation marks denote a string. So for Y label, this was frequencies in millihertz. I'm going to write frequencies. Frequency, and then open up a little parentheses and write MHz millihertz. Beautiful. Now
It's
let's give us-
microhertz.
Oh, it's microhertz, right? Yeah. Good point. So we can write microhertz. Well, this doesn't look good. So we're going to write a backslash micro. Oh, that didn't work out. So then we're going to do the same thing we did in Markdown. Surround this, or sorry, mu for microhertz. Surround this with dollar signs to denote that it's inside of a math section, and we want LaTeX to transform this backslash mu into a mu, or what stands for microhertz. Run that. There it is, mu. Awesome. Now, if that didn't work for you, you might need to put an R in front of this. It indicates that it's a raw string, and it'll feed it right into the LaTeX interpreter. Not important. Anyway, this let's see, what else do we need? Let's put in a title. plt.title. I'm going to write L new diagram. Awesome. Now let's turn this into the math mode, L new, L, like we did so many times before. Oh, doesn't seem like it's working. I guess this is the kind of situation where we need to transform into a raw data string. And we do that by putting an R in front of the string. Ah, beautiful. Now we got a really nice, really beautiful L new diagram. But can we do better? Yes. Yes, we can. All right. So how do you use a scatter plot in Python? No idea. Let's Google it. Matplotlib. matplotlib scatter. Open it up, and this is the called a man page. And this is when you're using Jupyter Notebook or you're using Python, this is going to be your best friend. You just look up Python, whatever you want to do, and boom, it'll give you a great description of every single object, every single library, every single parameter in that object or function, and it will give you examples as well. So this is our best friend. So scatter, X, Y, S, none, C, none. Let's check what X, Y is, the data positions. Well, we already did that. Data positions, X, Y, X is our L array, Y is our new array. So what else can we do with it to make it look cool? S, marker size. Let's change the mark size. S equals 2. No, I like this. Look it better. Can we do anything else cool to check it out? Let's see. C, array like or list of colors. Oh, this is awesome. So, how about we do that? C equals R. Interesting. Not bad. But we can do even better. So, if we remember our document, our ASCII encoded file, FR5, this thing over here, it has L values in the L values in the second column, new values in the third column, but fourth column, but the third column here has the values of every single radial order. So you know what would be cool? Yes.
Just to clarify, so in this data file, we have theoretical calculated eigenvalues, right?
Yes. So last week, you guys should have learned the equation for omega underscore NL for P modes. So like we have that dispersion relation, omega minus omega C over C minus lamb frequency over R times the Brun-Weishaar frequency minus omega. So for example, that's the dispersion relation for acoustic waves on the sun. So like when you guys last week, I'm sure you guys went over this, right? Yeah, so last week you guys derived a formula for acoustic P modes, omega NL equals whatever depends on the radial order N and whatever depends on the radial order L. And this is kind of like a similar equation, just way more complicated, solved to be more exact. So, but like, yeah, I mean, it's pretty much the same thing.
So these are lines which should coincide with the ridges on the observed spectrum, right?
Yes, exactly. So these are theoretically calculated for ridges in the observed spectrum, for the idealized ridges in the observed spectrum from a standard solar model.
So we cannot plot a color map based on this data, only lines.
We can, if we want to, but there's different ways to, there's different ways to work with data. I'm just showing you one specific example, but I'm sure you can come up with a way to like plot it into a 2D matrix and then create a contour and a color contour map that looks more similar to, so for example, this. You can do this as well, but it's a little more complicated. We're just not going to have time to get to that today. But like, there's a lot of ways to use this data. So one of the cool ways to use scatter plots is actually, we have this third column here, which is every single radial ridge has a different value. So we plotted around 7,000 different points. So for these 7,000 points, we know their L value and we know their new value, but they also have a corresponding radial ridge value. Let's pull that out right now. We can create a new array, control copy, control paste, and I'm going to write N array, not to be confused with new array. And N array is going to be our radial ridges. And it's going to be the second index. And let's print it out just to make sure. Print NR. Yes, now we have another 7,000 point array, which for every one of these 7,000 points has a different value depending on the ridge. Now, when we saw that C, it says array-like or list of colors. So they're just, and it asks for a scalar or sequence of n numbers to be mapped to colors using CMap and norm. We don't really have to know what that means. We just have to know that when we say C equals, we can make it equal to an array. And when you set it equal to NR, it means every time it plots one of these 7,000 points, it says, okay, what is its corresponding L? And that's its angular degree. What's its corresponding frequency? It plots that frequency. And then it says, what is its corresponding color? And then for the color, we mapped it to the radial array. So let's say it's ridge 18. It'll be like, this point has color 18. Let's say you're on a higher ridge, same L, different nu. On a higher ridge, it says, what's the color for this ridge? Well, it's the ridge number 20, so we're going to map a certain color to the number 20. And then when you write C equals NR, boom, beautiful. Every single ridge now has a different color. Oh, that was kind of hard to see here. I'm not really liking this color map. So one thing you can do is check what kind of options you have available. Go to matplot, matplotlib, color maps. Just Google it. Choosing color maps with matplotlib. This looks right. Tons of beautiful color maps. Let's do something that changes a lot because we have so many.
But we don't have a single color for each ridge. It's like a gradient of colors.
Well, it's a gradient, but each ridge is its own color. So like, let's say down here, the very first ridge is ridge 0, right? So it plots it out. It plots out a certain L value, and it plots out a certain microhertz, certain frequency value. And then so let's take the first index. The first index here is L equals 0 and nu equals 400. And then it plots it at the X position 0 and the Y position 400. And then it says, well, let's take a look at this array as the color map. So this is the radial ridge. So it's n equals 2. So it's going to assign an individual color to 2. So every time another array has the same 2, it'll have the same color because that's the color map. That's mapped to that number. So this L equals 0, nu equals 400, or omega equals 400, and then it corresponds to the second ridge. Now we're going to find, well, there's no second ridge, but whatever, let's do 20th ridge. So like we have L equals 0, omega equals 2000, and then we have ridge 20. So when we look at L equals 1, or one step over, one angular degree over, we have L equals 1, nu equals 2,967. So it's a little bit above the previous one, but it's still corresponding to the 20th ridge. So it'll still color it the same color as this dot right here, because we use this array or this vector for the color map. And it looks like it's just a gradient because it's just a bad color map. But what we can do is we can choose a different color map. Boom, this one varies really quick, HSV. So you do that. And then what we do is we write comma CMap for color map equals open and close parentheses HSV. Boom. Now it's a little bit easier to see that actually each ridge is its own individual color. And that's based on the array of the color maps that we gave to it. So as somebody who does helioseismology, or a certain type of a global helioseismology called deep focusing, where we're looking at flows within the interior, I don't really care about L equals 1,000. That those correspond to waves that are very much on the surface, and I'm not interested in that. I'm interested in looking at waves that probe deeper into the convective interior, which is from maybe around 0 to 200. So I don't really care about these L's. I don't want to see them. So what I can do is write plt dot xlim, and there'll be the limiting numbers for the x axis. And I'm going to write 0 to 200. That's the ones I care about. And boom. All right, this is perfect. This is exactly the type of figure that I want to put into my project, or maybe even print out to put into a publication. It looks great. Maybe add a caption to it. Markdown. figure 1, this L new diagram looks great. Good. Oh, doesn't look great anymore because figure 1 is supposed to be bold. And the way we can do that is put star star in front of it. And then after you want to end the bold region, you put star star. And that in Markdown, when you click Markdown on your cell, that denotes a bold face font. You can also italicize stuff with a single star, but we don't really need that. Now it looks fantastic. Awesome. We're kind of running out of time, and I don't want to steamroll through the next portion. So let me just take a breath here and ask if everybody has been able to recreate what I've been doing here, and if anybody has any questions. So were you guys able to all get to the spot? Anybody online? There's something you want me to go back to, something you wanted me to reiterate, something you were having trouble getting to work?
Excuse me.
Yeah, there are some lines that I missed.
Oh, well, sure. What lines did you miss? On the plot here?
Yeah, here.
Yeah.
Thank you.
And online, somebody had a question.
Yes, how do we put the label figure 1 in the center?
Mm-hmm. Say again.
I want to write the figure 1, the title of the figure in the center instead of left-hand side. So how do we do that?
Oh, it's not automatically in the center? So when you do PL, you can't actually change that. I mean, you can, but it's a lot more complicated to change it, and it doesn't work in PLT. You're gonna have to like define a figure and your own axis. But when you do PLT.title, just like this, it should show up in the center. Is it not showing up in the center for you? Is it not showing up in the center?
I think she means the caption.
Oh, the caption. Yeah, unfortunately, there's no real great option for that. It's not like LaTeX. You can just do that if you want. Although, for some reason, it took away the bold. You can just put a bunch of tabs, but for some reason, it takes away the bold face font. That's really strange. Well, suffice to say, Jupyter Notebook is not perfect. You should still use LaTeX if you want everything to work out completely. But the only way to really do that is to just move it to center yourself. Although now I'm realizing that for some reason it removes the bold. Yeah, there's not a lot of text editing options for.
Andre, but cannot understand like center line in LaTeX.
No, unfortunately, I mean, yes, it is possible because you can actually reprogram Jupyter Notebook with CSS commands. So you can actually write your own. So if anybody has experience with CSS or HTML programming, you can actually create CSS commands for each individual cell. Basically, it's really complicated, but and is definitely not within the purview of just the most basic stuff that we're doing here. But technically, it should be possible to edit notebook metadata, and you can literally write the CSS for the metadata for individual cells. But you're gonna have to figure that out on your own because that's very complicated. I don't think there's a way to center, does anybody know a way to center Markdown text? No? Yeah, I don't think there is, unfortunately. All right, it's physically possible to recreate Jupyter Notebook in your own image if you're like really good at programming. Like you can literally recreate like anything in LaTeX if you like do the right CSS commands, but it's quite complicated.
Okay, thank you.
Yeah, no problem. I don't know what happened here. Did everybody get everything working? Awesome. I'm gonna block this out, do *** to create a new line. and then I'm going to create a new section. I have no idea why this is inside of a.
I'm sorry, can I ask
Yeah.
you a question? About the lastly, how did you make the text bolded?
Right, the bold text. Yeah, you just do star star in the beginning, and then star star when you want to end the bold section, and boom.
Andre,
Yes.
you can do a HTML tag center and then /center.
Say again.
You can do an HTML tag.
Awesome. Like this?
Center and then /center.
Yeah.
Yeah.
Oh, beautiful. I guess you're gonna need the HTML tag for bold as well. What's the HTML tag for bold? Is it just bold?
I think it's the other slash. You did the wrong type of slash.
Oh, is it? Okay, I'll fix it.
I don't think you need to have the bold things.
No, if you want it to be bold.
Got the greater than sign.
Oh. How do you make bold stuff in HTML?
It's star star.
Oh, inside the brackets?
Without the brackets.
Well, without the brackets, it wasn't letting me for some reason. Oh, wait, I gotta.
/ there.
Right. Still not letting me do bold.
I don't know. It was working for mine.
Try
Strange.
putting a space after the first sentence.
Andre,
Yeah.
yeah, it's just B. For bold, is using letter B.
Oh, okay. Yeah. So in CSS, I guess you can just do B and then close
Yeah,
B,
close
right?
B. Yeah.
Beautiful. There we go. So if you know CSS, then you can do whatever you want.
Please click to show the code.
Oh, sure, sorry about that. Yes, it's just open right center to center the text, right B to create the bold, and then close it off with /center. And yeah, and basically you can do this with, you can do whatever CSS stuff you want to try to make your text look nicer. Everybody get this? And thanks a lot for the help online. Awesome.
This is called HTML language.
Yeah. This is just basically HTML.
For website, yeah.
Mm-hmm.
Andrei, so you'll show the feeds files tomorrow?
I guess. Well, tomorrow's lecture is going to be. I don't know if we're going to have time after tomorrow's lecture. I can really quick show fits files right now, but we only have like 10 minutes of class left, right?
It's a couple of minutes, yeah.
Yeah. Well, real quick. If we're not able to get through it, then if we have time tomorrow, I'm going to show it. Also, I'm going to upload a full. Actually, first, I want everybody to save the Jupyter notebook. Save as in documents, plotting. Save. Or whatever name you want, LNew diagram. I already have a Jupyter notebook saved as LNew diagram because this is the what I was doing. So what I'm going to do is I'm going to upload the Jupyter notebook that was supposed to, after tomorrow's class, I'm going to upload the Jupyter notebook that was supposed to be today's lesson. And it has a bunch of different stuff in it, like this LNew diagram, how to open fits files, plot them, and as well how to make simple animations. But we won't get to that today. But if we don't get to it tomorrow, I'm going to upload the full Jupyter notebook with how to read and plot fits files, as well as how to make simple moving animations within the Jupyter notebook. But we probably won't get to that now. So let's do as quick as we can to get to reading dot fits files. Boom, new paragraph. Markdown. Let's put another bunch of stars. Star. And now do another markdown to explain what we're doing. First, we need to import the fits package. So the way we do that is import astropy.io. It works. Awesome. Now, sorry, what's your name?
Ivan.
Huh?
Ivan.
Ivan? Ivan, you're on Linux, right?
Yep.
Does import astropy.io work for you?
Let me check first. It seems it works.
It works.
It doesn't show any error messages.
Awesome. So astropy is not the most common package to have. If you're running Anaconda on Windows or Mac, you're definitely going to have it. If you just install the bare bones Python 3 in Linux, you might not. So astropy is just a library for like astrophysics stuff for Python. And if you're running bare bones Python on Linux and you don't have this, very easy to install. You just do pip install in your terminal. You just do pip install astropy if this is giving you an error. I'm not going to go over that now, but this is how you can install it. So we want to import astropy.io. Specifically, we want to import fits files. So from astropy.io, I'm going to import fits. Fantastic. It works. So now we're going to be opening the files. Let's do ls real quick again. Just take a look at the files that we have. We have this ifun cs.frs.fits. So let's open up that first. The way we do that is we do hdul equals, and this is just a variable. You can do whatever you want. You can write fits file if you want. The reason it's common practice to do hdul is it stands for HDU lists, or header data unit list. It's just terminology that's used in fits files, but it can be any variable. It's just opening, like we did file equals for opening a file. You do hdul equals fits.open, and then same thing we did last time. We want to open ifun cs. We do ig, press tab, and then we can choose one of these auto-completed ones. Do cs, and then shift enter. Worked? Great. Now we want to know what we actually opened when we opened the fits file. So the way you can do that is do hdul.info. So that's just the object. You have to open and close the parentheses to get the readout of the object. So we run hdul info, and this gives us information on what's inside the file. So inside of an HDU file, it's usually going to be several variables or several data cards. So for example, it's going to say number, and it's going to be 0. It's going to be the name of that data card, and then it's going to be the type, and it's going to be the file size and the dimensions of the array. The array is of length 1,000, and the format is 64-bit floats. So you sometimes when you open a fits file that has more than one card, it's going to be like number 0, and then it's going to be like number 1, and it's going to be just a totally different variable with whatever dimensions it has and whatever format it has. If you're interested in choosing a specific card, all you need to do is do hdul, open and close brackets, 0. The number 0 card is the one we're interested in looking at. And then we say we can extract the data from it by doing .data, and then it will extract the data from the array. It also has a header that we can access by writing .header. And it will give us a little bit of information about that data. So we read HDUL, the total info of the HDU list, then we take the single card from that list, and we can check its header, and we can read out its data. Awesome. Fantastic. Bunch of numbers. So what we're going to do next is we're going to open the next file. And since we want to, yes?
Is HDL NumPy array?
Great question. Yes, it is. It's an array. The format of the array is float 64, which means they're float numbers, which means they're actual numbers that can be used. They're not like characters like the lists were. So these are all numbers, and whenever you see array, it's like an actual array instead of a list. Basically, yeah, we're not going to have time, but let's just call this HGLCS, HGLCS.info, HGLCS, HGLCS.data, and then we're going to do the whole same thing over again for R. For R. And then since they're already read as HGLR, 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 HGLR. Awesome. Since they're already read as NumPy arrays, you can just dump this data into a variable like CS and R, and that dumps the data into a variable that's automatically a NumPy array because HGLCS0.data is a NumPy array. And we can print them out now to just make sure. Print CS, print R, and that's about all we're going to do today because we're out of time. You can quickly plot them if you want. X-axis R, Y-axis CS. Get a plot like this. And inside this fifth file, CS is sound speed in the sun, and R is the corresponding radius of that sound speed. So if you Google sound speed inside of the sun, you're going to see a plot much like this. So the first FITS file, eigenfun cs_frs.fits, turned out to be a FITS file with 1,000 indices sized vector full of sound speed variables, and then eigenfun R turned out to be a FITS file with the corresponding 1,000 index vector of the radial points inside the sun from 0 to 1. So this is just sound speed inside the sun. And this is all we were able to get to today. If we have any time tomorrow after the lecture, so I'm also going to be teaching the JWKB approximation lecture tomorrow, which is for G modes, for the gravity modes. If we have any time left over that lecture, we can go back to Jupyter Notebook and try maybe saving and writing our own FITS files, or doing simple animations, whatever we have time for, whatever people are interested in. So yeah, class is over. It's 1:30. So thank you or 2:30. Sorry. Yeah.
Oh, thank you, Andrei.
Yeah, thank you very much, everybody. And if you have any questions, just let me know.
Can you share the Jupyter notebook to us?
Yes, I will be sharing this Jupyter notebook, the one I just wrote on here. I'll be sharing that in the same folder on Canvas that you guys downloaded the data from. And if you have any questions, don't hesitate to email me. My email is ams226@njit.edu. Code markdown.
Andrei,
Email
maybe
me.
you can, yeah, we finish our class today. Thanks, everyone. Andrei, maybe you and John can stay for our meeting in classroom and
Yeah, sure, definitely, absolutely.
Can I ask a question?
Yeah, go ahead.
I'm getting an error, unexpected error while saving file. No such file or directory, and then like the file name has 2 slashes all the time.
Well, so whatever notebook directory it's in, you should just save it there. And don't do slashes, just try L-new diagram. No slashes, just all one word. And then you don't have to do if.pynb or anything, just click save. That's not working for you.
I can share my screen.
Yeah, can you? If it's not working for you, you can click download as notebook IPYNB, and it'll just download it to your computer from the server. But yeah, if you share your screen, I don't know, Professor Sochev, if you can give the sharing rates, or I don't know if how that works.
to give to Bryce?
Yeah,
Okay.
yeah.
Okay, okay, Bryce, you can share your screen.
Yeah. Go to Jupyter Notebook. Awesome. Fantastic. Save. Yeah. There shouldn't be a percent. Oh, this is the problem. You saved it into a path that has a space in it. Yeah. You just save it in documents. No, yeah, just save it in documents and then you can move it later. Or you can do that, yeah. Yeah, it's fine. No
Okay.
big deal.
Well, that's fine.
Yeah, just click File, Save. Yeah, File, Save. And just delete Jupyter 20 tutorial. Yeah, just save it right in documents. Or no, name it. You gotta name it.
Okay.
There we go.
Thanks.
No problem. Any other questions? All good. Anything else? Anybody else?
I had a question about possibilities to export the data from Jupyter Notebook.
Yes. What was your question?
Or can we export to PDF or?
Yeah, absolutely. Professor Sovichev, if you can give me back screen share for a second.
Yeah, you're presenting.
I'm presenter.
Yeah.
Okay. Awesome. Okay, so if you want to save it as anything else, all you have to do is do File, Download As, and then you can do HTML, LaTeX, PDF via LaTeX. So, and you can, I guess, like an easy way to share with people would be HTML. You just download it, save it as HTML, and this is what it's going to look like. You can just open it in any browser or send it to anybody over email, and without Jupyter Notebook, they can just open it up and read everything that you have. Or you can save it as PDF via LaTeX, probably the best way to do it. But sometimes it doesn't work because you need a LaTeX writer. But I don't know, maybe PDF via, no. So you need to
But you
install a
can print
PDF
probably
writer.
as PDF, right? Can you print as
Say again?
PDF? Can you print
Yeah,
as
well,
PDF file?
Yeah.
If you go
you
to
should be
File,
able to.
Print.
Yeah, you can do Save Page As, and you can do, no, I guess you can't. But you can print this as a PDF if you want.
So we need a LaTeX compiler installed.
Yeah, you need a LaTeX compiler installed, or you need a PY, whatever, I don't know, I've never used that. So like you need a PYP type that's here. You'd need that installed. So you'll need either a LaTeX PDF compiler installed or this thing installed. The easiest way to save it is just either as a notebook or as HTML. HTML is easy. You can easily share it with anybody else. Yep. Any other questions?
So other programs in the Jupyter Notebook run on the server or on your laptop?
They run on your laptop. Your laptop is the server. So, for example, you were on Linux, right? And you click terminal and you wrote Jupyter/lab and you run it. And now you can see in your terminal. And so if you click back to the terminal that you ran it in, it's actually still running it.
Oh,
So what it does is it goes into your computer. It runs a very basic shell that's a server. It takes the Python 3 client that's found on your computer, and it uses it as the kernel of this mini operating system that you're running a server on your computer on. And then when you when you're in the web page, it says localhost 8892 or 8800 or 8080, and that just means that you're accessing the internet, and then you're going to the router and you're redirecting the traffic right back to your computer in a port 8892 for me. So it goes from the router and then it actually bounces right back into the server that your computer created on port 8892 for me in your, I guess that's a little complicated. But basically you run the server on your own computer.
So it's just a browser interface.
Exactly. It's a browser interface for a virtual server that you started on your own computer.
Clear.
Yeah. Any other questions? Awesome. Well, thank you very much. This is class. So, yep, you guys can go. If you're online, feel free to sign off. If you have any more questions, we don't have time anymore because we